Hello everyone, we're discussing Earth's magnetic field and so far we have discussed this thing that at any one place horizontal component of Earth's magnetic field is BH and vertical component is BV. This is the horizontal component, this is the vertical component. Then complete a rectangle join this, it will give you B, which is total magnetic field. Total magnetic field. This angle is what? Theta. And this theta is called angle of inclination. So this is theta. I'm asking you a very simple thing. In terms of BH and BV, write down B in the comment box and write down value of theta. Write down magnetic field B in terms of BH and BV, and also write down what this angle. So B is coming root over BH square plus BV square. This is the horizontal component, this is the vertical component, this is angle of inclination or angle of dip. Then this B, how do you draw vector sum? We complete the rectangle like this and then you join the diagonal. A simple vector thing which gives you B in this form. And in this right angle triangle, if you look for tan of theta, then tan theta is what? BV upon BH, which tells us that theta is tan inverse BV upon BH. Tan theta is tan inverse BV upon BH. So if you can measure horizontal component, if you can measure vertical component at any place on the surface of Earth, then you can easily find what? Total magnetic field. At the same time, using this, you can find angle of dip or angle of inclination. Note down this. Now just tell me, what is the requirement which I told you? Let's see if you remember that part. If you want to measure this theta, then what is the requirement? Basic requirement. If you have any idea of that, if you remember what was told to you in the previous lecture, then write down this in the comment box. Let me give you a hint. You're standing at some place, you measured horizontal component, you measured vertical component. Is that all? Or you need to take care of something? Yes, almost. So, I hope you remember this way. When I explained the whole thing, the logic was, first of all, let's say my hand represents the needle, magnetic needle. So this is pointing in this direction, suppose. First, you will place the magnetic compass in the horizontal plane. For the time being, assume this is your magnetic compass, and inside you have a magnetic needle. So once you hold the magnetic compass in the horizontal plane, this needle can rotate freely, and therefore it will point towards north, giving you what? Magnetic field line. So the magnetic field line which you got is this. Through this line, you have to erect a hypothetical plane. So the vertical plane which you will erect is the plane of magnetic meridian. In that plane of magnetic meridian, now your magnetic compass is placed like this. Again, if you can feel this thing in the video, if I hold the compass this way, then it will not give me proper angle of dip. For proper angle of dip, compass should be held in the plane of magnetic meridian. Write down this statement. For proper angle of dip or angle of inclination, for proper angle of dip or angle of inclination, magnetic compass should be placed in the plane of magnetic meridian. It's a vertical plane and we'll call it plane of magnetic meridian. If you have space, just draw this type of boundary. This whole thing is a vertical plane which is containing north-south orientation. Which north and south? Not the geographical, but the magnetic. And therefore I'm using magnetic meridian. In that magnetic meridian, plane of magnetic meridian, if you hold your compass, then its needle will give you proper angle of inclination in this case, and if it points like this, it will give you angle of dip. Mention this part. Now, suppose we have a plane, a different plane. If we have a different plane, an angle between these two planes is phi. This is plane of magnetic meridian and this is some other vertical plane. An angle is what? Phi. This is magnetic meridian. The angle is what? Phi. In this second plane, if I hold my magnetic compass, then find out new angle of inclination theta dash. In the plane of magnetic meridian, angle of inclination is what? Theta. In this new plane, which makes an angle of phi with the plane of magnetic meridian, you need to find angle which the magnetic needle forms, theta dash. Let me give you a visualization first. So this is your compass That's the needle in the horizontal setup. The marker is giving you direction of magnetic field line. If I hold the compass like this, needle will point in this direction, giving me angle of inclination theta. If I keep the magnetic compass in a vertical plane which aligns with what? North-south line, magnetic. In short, it is called what? Plane of magnetic meridian. Plane of magnetic meridian. Now, if instead of holding my compass in this plane, I rotate the whole thing by an angle of phi. Instead of this, if I make it this, just so that you can visualize it, instead of holding this way, if I rotate it by an angle of phi. So in this new plane, which is not the plane of magnetic meridian, any random plane with angle phi, find out theta dash in terms of BH, BV and phi. Let's see if you can answer this part. We've got 1 minute's time. And the trick is, this diagram will help you in understanding this question. No. Okay, let's solve the question step by step. Answer this part. There is no magnetic compass. Forget about magnetic compass. Somebody told you that this is BV, this is BH. Look here. You can see the colors: blue, black, red. This blue marker is for vertical, black is for horizontal, and this is the red one. It gives you total magnetic field. This is the original setup in the plane of magnetic meridian. There is no compass, forget about it. Now, if I ask you that, what are these components, not in this plane, but in a different plane, a plane which makes an angle of phi. So what I have done, this, instead of giving you values in the original plane, I'm asking you values in the different plane, and this angle has been given what? Phi. In the plane of magnetic meridian, values are what? BH and BV. In fact, write down the question in detail, maybe then you will be able to answer the whole part. BH and BV are magnetic field components in the plane of magnetic meridian. BH and BV are magnetic field components in the plane of magnetic meridian. Which is a vertical plane that contains magnetic field line produced by Earth. Magnetic field line produced by the Earth. So you have Earth as a bar magnet, and that bar magnet of Earth, this is north, this is south, but you know magnet wise this becomes north. We have done this thing. That's how magnetic field line runs. I've drawn this thing up because we have already done this part. This line is the actual magnetic field line. The plane in which this line is present is your plane of magnetic meridian. Now the question says, find out angle of inclination theta dash. Continue with this. Find out angle of inclination theta dash in a different plane, vertical plane, which makes an angle of phi, with the plane of magnetic meridian. So the only thing you need to find is what? You need to investigate. Instead of this, if I hold the compass in a new plane, then what happens to these two components? I'm giving you a hint. Tan of phi dash will be same BV dash divided by BH dash. Same formula. Theta dash, BV dash, BH dash. If you can find BV dash and BH dash in terms of and this angle phi, then you will get the answer. This is more than sufficient hint. Last attempt. This is BV, this is BH. If I rotate, there is one component which is not going to change. Which one is that component? Mention this in the comment box. There is one component which is not going to change. Good, at least you have answered this part correctly. Your BV dash will be same as BV. Why? Just look here. This is the original plane. And as I rotate, well, there is a very good thing which you can feel with the help of this whole part. Maybe you can see that the way I am holding these markers, this tip and this tip, they almost match up with these tips. Now, I hope you can see that I'm trying to produce the alignment. You can see that this tip and this tip, they align with these two. Now, as I rotate this part, what is the component whose length you find changing? Then I hope you can see this part is same, but this component which was from this point to this point, as you rotate it, its effective length you can see is continuously changing. From this, it is continuously changing. So, when you rotate the magnetic compass by an angle of phi, it's the vertical component which is not going to change. Write down this. When we rotate magnetic compass by an angle of phi, vertical component will not change. So if I say that vertical component is not going to change, then it's the horizontal component which is going to change. Now just find out value of BH dash and write this in the comment box. Just write the value of BH dash, which in itself is an objective question. They won't ask you anything. They can simply ask you that magnetic compass is rotated by an angle of phi, keeping it vertical. Then what happens to vertical component? It will remain same. What happens to horizontal component? That's what my question is. You just need to figure out BH dash. Should not take more than 10 seconds. You're very close. Just take care of the thing which you have written. Your answer is almost correct. But just look at the answer once and you will find there is a silly mistake in it. Otherwise, no, still not correct. I don't know what makes you produce all the wrong answers. You're supposed to write this. BH dash is BH cos phi. If I draw the top view, so if we look at these two components, not from this side, but from this side, which is called what? Top view. If I draw the top view, and I'm interested only in what? The horizontal component part, then it will look like this. This is BH. This is BH dash, and this angle is phi. BH dash, and this is what is phi. You will understand it this way. Vertical, horizontal. This is BH dash. And this green marker, BV, B horizontal, and the green marker is BH dash. This is the top view. If I draw the top view, it will look like this. Forget about this for the time being. Vertical component, forget about it. This is the horizontal component, and this is BH dash. This angle is phi. That's what I have drawn. So what is BH dash? It is the cos component of BH. That gives you BH cos phi. Now if you understand this part, then write down yes in the comment box. Because this thing in itself is a very good objective profile. BH dash is BH cos phi. BV dash is BV. If you understand this, then write down yes in the comment box. If you do not, then tell me what exactly your confusion is. And if you cannot say yes, you cannot say no, then you are kind of useless. Good. So, what about phi dash? We've got the value of phi dash as you got the value of phi dash tan inverse BV dash, which is BV, divided by BH dash, which is BH cos phi. Note down this. Now suppose they ask this question as an objective one, and in that objective part there is a second option which looks like this, which some of you answered, and therefore I am presenting that option as a second option. Suppose phi dash is given in this form: tan inverse BV divided by BH sine just a small mistake, not a mistake, presentation problem. This was not called phi dash, this is theta dash. I think initially I gave you as theta only. So your angle of inclination is theta, and the angle of inclination in a new plane, let's use proper representation, this is theta dash, and everywhere where you see phi dash you will make that theta dash. Just make this correction, theta dash, theta for angle of inclination or dip. This is theta dash, this is theta dash. Phi we have used for angle between the planes. So your theta dash in one of the options was BV upon BH. Instead of cos phi they gave us sin phi. Write down in the comment box how can we prove that this option is wrong without using much of maths, without using all these visualization and all. How can we prove that this option is not a correct option? This was given, you had the idea of tan theta, everything. How can you prove in just 5 seconds that this option is not correct? Taking too long. If I say phi is 0, what was phi? Phi was angle between these two planes. This is the actual plane of magnetic meridian in which magnetic field line is present. This is another plane. So if I say phi is 0, if phi is 0, you are present in which plane? In the plane of magnetic meridian. And if you are present in the plane of magnetic meridian, then what is theta? This. So if I put phi equals to 0, this becomes sine 0. Something upon 0 infinity. You're getting a totally different answer. Look here, if you put cos 0, what is cos 0? 1. Theta dash is giving you what? BV upon BH. BV upon BH. So you can remember this in this form. This option is wrong. And why is this wrong? Because of the reason, if phi is 0, then theta dash should become theta. And because of this option is not a correct one. Mention this. Now write down a question. Strength of magnetic field at some place is 5 Tesla. Oh, this is too big, but just for the sake of calculation, go down these values. That magnetic field of Earth at some place is 5 Tesla. Angle of inclination is 53 degrees. This is Earth's magnetic field. This is angle of inclination 53 degrees. Find out angle of inclination in a plane which makes an angle of 37 degrees with the plane of magnetic meridian. The time starts now. Let's see how much time you take to answer this question. Everything you need is present on the board. This is 37 degrees, 3, 4, 5, and this angle is 53. So if you need sine 37, that will be 3 by 5. But if you need sine 53, that will be 4 by 5. that is more than sufficient time to answer this question. I'm asking you find theta dash. I told you everything is present on the board, but still you are taking this much time. We have been given total magnetic field. Angle of inclination is what? 53. So you have been given this 5. This is 53. 37 is 5. The only thing you're supposed to do is this. And you're taking enough time for that. BV is what? B. This is BV. This is theta. So what is BV? B sine theta. B sine theta divided by BH. B cos theta. So I've not given you these values directly. What is BH? B cos theta. Then you have a term of cos of phi. Done. That's your theta dash. Tan inverse B gone. Sin theta upon cos theta, tan theta. This is theta. This is B. So what is sin theta upon cos theta, tan theta? What is tan of 53? Let me write down tan 53 first so that you don't have any confusion. Cos of phi. What is phi? 37. So what is tan 53? 4 upon 3. Tan is what? Perpendicular upon base. So this gives us tan inverse tan 53. 4 by 3. Cos 37. What is cos of 37 in this figure? 4 by 5. 4 by 5. 4 and 4 cancelled. And the answer is tan inverse 5 upon 3. That's the answer. And not a single person could answer this. So when everything is in front of you, you're not able to answer this question, then imagine what will happen during the exams. Now answer this part. What is magnetic field strength in this new plane? Find out magnetic field strength in the plane which is at an angle of 37 degrees. Answer this. show me something, at least produce a correct value for this question. Total magnetic field in the new plane. And you guys are extremely special. You don't answer nothing. But the problem is that if you cannot answer these easy questions, then how will you survive? If forget it. Look here. I'm asking you B, which was what? Still on the board. What is B? BH square BV square. But this time I'm asking you B dash, which is BH dash BV dash. That's all. BV dash, vertical component, it doesn't change. B sine theta. Sine 53. Sine 53 is 4 by 5. 5 and 5 cancel, this is 4. We know that vertical component will remain same, and therefore BV dash is simply 4. BH, this is BH first of all, which is B cos theta. Let's put the values directly now. 5 cos of 53 is 3 by 5. Cos of 53, if you are finding cos of this, that's the base, 3 by 5, which is 3. But this is not 3, because BH dash, you know, is 3 cos of 5. And then go for the square. This is your BH dash. And this is your BV dash. BH cos 5. 16, 9, cos 5. What is 5? 37. What is cos 37? 4 by 5. This 5 is there, 37. Cos 37 is coming from this 4 by 5. Square 16 by 25. This is coming, take 16 out, which is 4. Take 25 out, which is 5. Root over 25 plus 9, which is 34. That's the answer. Do you understand this question? Yes or no? Answer this question. Write down the question. If magnetic compass if magnetic compass is held if magnetic compass is held in a vertical plane if magnetic compass is held in a vertical plane which is perpendicular to the plane of magnetic meridian, if magnetic compass is placed in a plane which is perpendicular to the plane of magnetic meridian, then find out angle of inclination. Then find out angle of inclination. Answer this. I hope my question is clear. This is the plane of magnetic meridian, actual north and south. And if I rotate the magnetic compass from this plane and bring it into the 90-degree plane, which is like this. Instead of holding your compass, in north-south plane, hold it in east-west plane. I hope you understand the question. You found the direction of magnetic field, but I don't want you to place the compass in this plane of north and south, but in the plane of east and west. So the plane of east and west, what will be the angle of inclination? And there is not a single answer so far. Well, please don't mind, but I will suggest you that, which I always do in every class you have seen, that this batch is spatially weak. Please don't mind. And if you do, that would be a good thing, in fact. So what you should do, you should work hard a lot. Normally I give a target of 100 to 200 questions. But for you guys, it should be 300 questions at least of any given chapter. Now it's up to you if you follow the advice or not. Solve at least 300 questions, then only something good will happen to you. Because the question I'm asking you is, one of you has answered something. Well, I'm asking you the value of angle of dip or angle of inclination. If instead of holding the compass in the plane of magnetic meridian, you rotate the compass by 90, then what is the angle of dip or angle of inclination? That's what I'm asking you. So what I was asking you is this. I'm asking you theta dash. And just because I erased the formula, you could not. You are supposed to answer this. I'm asking you theta dash, and I've given you phi 90. Can you answer the question now? I have written the formula on the board. I have told you, I have given you the value of phi. What was phi? Phi was angle between the planes. Phi was the angle between the planes. Which this time is 90. For the sake of God, at least answer the question now. Everything is in front of you. And I'm telling you, if after 1 year you happen to watch these lectures, then you will realize that you are committing some silly mistakes. These are not difficult things. If you are fearful of these things, then let me tell you, you will realize this after 1 year, but that 1 year will be gone then. So, I'm telling you that phi is everybody is answering that theta is 0. Everybody answers that theta dash is 0. You have the formula in front of you, but you are answering that theta dash is 0. What can I do? What is phi? 90. What is cos 90? 0. So BH into cos 90. Cos 90 is 0. What is something upon 0? Infinite. So this is tan inverse infinity. Something upon 0. And what's the value of tan inverse infinity? 90 degrees or pi by 2. And you're answering 0. The answer is what? 90. You had the formula, you had every value, but still you are answering this. So you can see when I say that you need to solve 300 questions, you know why I'm saying this. You will commit these mistakes and then you will realize that, okay, this was the problem. Now, I hope you understand this, but in just 10 seconds, let me give you the visualization. There was no need to write everything if you had understood the concept. This is BH, this is BV. The actual plane of magnetic meridian. In 5 seconds, you can answer the question. Now, if I rotate the plane by 90, for the time being, I'm keeping it out. This is BH. What about this? Any vector has no component in a direction which is perpendicular to it. So this BH has no contribution in this direction. This is gone. So over here, when I rotate the compass by 90 degree, only this BV will be present. So what is this? This is the magnetic field line. If you allow the needle, then it will point what? Vertically up. What is vertically up? What is vertically up? Vertically up means an angle of 90 degrees, which for you is a result. Note down this much and then you can leave. Thank you very much.